I kind of rushed it on that last problem, but if you have any questions, let me know. One of my students told me he hates these problems with people moving around with speeds and times. But I'm going to make it much more real to you in a second. You're given here in number 18 two graphs, and you're asked some questions about, you know, who's traveling faster, etc. It's obvious to me because I'm used to looking at graphs all the time. It's also a little bit artificial because they have these, it's a made up problem, so that's why. So let's look at real problems so that we can understand what this looks like in real life. I took data from 700 of you for running the two miles. Now, females are not going to start 10 minutes later, so I'm not artificially going to change that. Everybody's going to start at distance equals 0. And their time is not going to start in any differently than before. So here, if you go back and look up here, Jerry left 10 minutes later. That means that it had a 10-mile head start, basically, for Jade. But here, we put everybody at 0. That's the difference between the two problems. And what I did is I just graphed the average female run time for the 2 mile and the average male run time. And you can see from looking at this, it's obvious males are faster. Males are faster because they covered that distance in less time. It's 2 miles. How do we use, like, we're going to make an assumption. That other problem doesn't say this, but we're going to make an assumption that the speed is constant. That's not really the case. I took the ACFT. I felt like I was going to be sick by the 2 mile run, and you know, I was barely running. I was probably doing a ballet jog through the whole thing, and then at the end I was scared I was not going to pass, so I sprinted the end. So I didn't do a constant run, but okay, whatever. Let's assume that. How do I calculate speed if it's a constant? Well, you use what's called the DIRT formula, distance equals rate times time. And then the distance, total distance is 2. The total time run by males is 15.02. So the speed of the males is 2 divided by 1502, or 0.13 miles per minute. I got the units on there. It's miles per hour or miles per minute. You have to get the, whatever your axis is here, it's the bottom part of your ratio. Whatever your y-axis is the top part of your ratio. Now, the way that you're expected to do the previous problem is to use slope and recognize that slope is actually speed. And so you could say, well, I'm going to do y2 minus y1 over x2 minus x1. Well, what would that be? The females go through the 0.00 and they go through 16.64 and 2. So my y2 would be 2 because that's the endpoint y value. My y1 would be 0. My x2 would be 16.64 and my x1 would be 0. So that's the way you would do it. And in your case, your second point for one of the graphs is not 0 for y2, it's 10. So this is the better formula to use. That's why I say that's what was expected of you in that particular problem. So if I do that calculation, I think I didn't finish it. Yeah, so I think I just wanted to show you this. Like here, your y2 is going to be 10. I get 0.12 miles per minute, and now you can see the females are indeed running at a slower rate than the males when I do this calculation. Old folks like me also did a very slow rate. I'm not going to give you my runtime score, but after sprint, drag, and carry, I was pretty beat. So I'll do better next time.